jealous that I'm not the amazing critical thinker that you are.
Yeah, what's 1.9 though?
It's a comma, you.
Let's settle this and let's have a physics battle.
N1, N2, N1.
Physics battle.
I think it's supposed to be
Look in
a.
your packet.
I'm pretty sure this is supposed to be a comma.
So what? So like, how is there two final velocities? Oh, it's two objects.
Two different objects. Object 1, object 2. The two objects' initial momentums, the two objects' final momentums. Okay, put this in your note card quickly so that we can progress. Get to the math problem and things like that.
Math. Total initial momentum equals total final momentum.
What?
So like do this like.
Hey, look, how about we stop that and we actually focus on physics?
Amen.
I'll help you.
I'm sure that's not a high quality life lesson.
Yes, it is. It's more important than physics.
Jesse!
Jesse, don't
Watch me! Please, Leslie.
freak out.
I need to take a class.
Okay,
No.
got it?
No.
Why are there commas and stuff?
Yeah.
Because it's saying like
Clicking your
the
list.
velocity of the
Kramer,
first
they're
one,
on the same
initial,
side,
velocity of the
makes
second
no
one,
sense.
initial.
Alright, here we go.
Why is it staying on both sides?
Everybody open up your books to page 197 so we can look at a picture of the
Oh my goodness.
Are we gonna close our eyes?
This is the second time I've opened my physics book this year aside from
Oh boy, that's so wrong. Brain will not be able to do that in advanced chemistry.
Right, just taking content.
Alright, you ready? Here we go. Taking a look. Here are two billiard balls. Okay. This was the result of one of my really bad things I said in class one time.
I hate it.
Okay. So far we've considered momentum only on one object at a time. Now we're going to consider the momentum of two objects colliding and interacting with each other. So you can look in the three little visuals there. That I like how it shows how A is moving. Yeah, isn't that clever? Wow.
Wow, they added a visual effect to Photoshop.
Okay, yeah. So A is moving, B appears to be at rest. Okay, then A hits B. A probably was moving a little bit, but at the end, all of A's momentum was transferred to B. Okay, so I want you guys to know that when we're talking about momentum being conserved, we're not saying that the first object's momentum will always be the same. We're saying the sum of their momentums are going to be the same. We're transferring momentum from one object to another. Yes.
Is that in a frictionless world?
Yes. Yes. Now we could say, well, I'm not going to do that.
Total momentum.
Does that mean we can go play pool for physics? To worry about how.
Yeah, let's go to Big Dom Billiards on East 14th.
Yeah, let's do that.
I don't play pool well, so.
Okay. Okay. So before the collision, what is the momentum of ball B?
0.
0. Okay. So here we go. Let's say that this is the white ball and this is the red one. Okay. So red's momentum initially is what?
0.
Okay. Let's just make up white's momentum. Let's say it's 25. Okay. Then at the end, after the collision, A's momentum, or the white ball's momentum is 0, and the red ball's momentum is, do they equal?
Yes.
All right.
It goes. Oh yeah, that's not.
Momentum is transferred from one object to another. Now we're assuming, we're going to also assume that energy isn't dissipated in the form of sound, I'm guessing in this situation.
Heat, or light.
Yes, but we like it easy, don't we?
Yeah, they're.
If you crush lightsabers,
Hey, quiet, please. Have a problem already?
Let's do the question.
Yeah.
Oh, I want to talk about okay. Momentum is conserved when you push objects, like if two stationary objects push each other. So like if Cole were to stand up, he doesn't have to. If we were to both stand and I pushed him, we both would go the other direction. Momentum would be conserved in that case because you'd have opposite signs. And you'd have your action and reaction. And momentum would be conserved in that situation too. When you jump off the ground, momentum is conserved between you and the earth.
Oh my word.
Going from zero momentum to both things having momentum and still conserving momentum.
Opposite direction.
Yeah, but like,
Because what you'd have is like you'd have 25, sorry, why did
yeah, I get like it'd be like 25.
25 minus
Yeah.
25, 0 would equal 0 and 0. Okay? So, but what I'm saying is when you jump off the ground, you have a certain velocity. Well, the Earth also has a certain velocity, doesn't it? But that velocity that the Earth has is extremely what, Avery? We're not listening to me.
Big boys. Very much gone.
Very much Okay? So when I jump off the ground, I have a velocity, but so does the Earth. But the Earth has an extremely small velocity. Why?
Because it's
Is
huge.
it their mass and velocity in play when we talk about momentum?
Wait, so you're saying when you push off, you're pushing the earth,
Yeah.
but it doesn't move because it's so
Well, it is moving, but like times 10 to the negative 30 something.
Oh.
That you can't know.
Everyone
That's why he said
but not.
everyone comes to the same. Everyone in the universe comes to the same area, and we all jump. Could we significantly move the Earth?
Could
The
we?
answer is no.
Why?
Because we don't have enough mass.
we all start-
we've never done it
What if
before.
all-
They brought everything on the earth to that spot.
If that were true, maybe I don't know.
What if we all
the-
jump a bunch of times?
No, I mean like these are houses.
Okay.
What? Are you
Jump.
sure, Cheyenne?
Everyone has a tree. Jump with the people.
Everyone has to.
I love this. A 76 kilogram boater.
Oh wow.
Motor, I hardly use it jumping.
Remember when Autumn did that?
How is he not making
Well, I don't get it. Stop. I think we did it.
I know.
Stationary for
Buoyancy.
But still.
Alright. Ready?
Yeah, that's a big start.
Alright, guys. You need to stop touching someone's hair, please.
Brains.
PDA.
It's not PDA.
It's PDP.
public display.
Diesel something dude. Parental distraction, dude.
Parental. Physical distraction, dude.
Okay, yeah.
Frames is my dad.
Hey, no.
Alright. So we got a 40. Where the heck did I get 40? 76 kilogram boater, initially at rest, in a stationary 45 kilogram boat. Steps out of the boat and onto the dock. If the boater moves out of the boat with a velocity of 2.5 to the right, what is the final velocity of the boat?
He's going to the boat.
Yes, that's okay. Buoyancy, more surface area.
What's the point?
I promise you. Alright, so give me some variables.
Mass
Mass.
is 76
Okay,
plus.
we need to clarify.
One.
We can call it M1.
Wait, so buoyancy is strictly determined by surface area?
V.
No, not
no.
Okay.
Initially, it's
But it
VI.
helps.
VI1.
You know, most like mega ships have, because of the air that they have in the boat, they can have an outrageous amount of people in a boat and still be fine.
M2, 45 kilograms.
V1I is
M2 is what?
You know what? Do you go in order?
Got it.
45.
I am going in order. A 76 kilogram motor initially at rest.
Okay, what else do we know? Bryce, one more thing.
V1I is 0.
Why is V1I 0?
Because it's initially at rest.
Okay, so does that mean V2I is also 0?
Oh my word.
Well, I mean, depends when you start.
Isn't the boater in the boat?
Yes.
The boater's in the boat, right?
Yeah, it's 0.
Correct.
Okay.
So the boat isn't moving?
Nope.
Oh my
The,
god.
There's nothing in here that suggests that the boat is moving. Is there?
Well, wait,
Stationary
it depends on when you start the
Doesn't it
thing.
say stationary boat?
Yes.
Well, it depends on when you count it starting. Because like if you start with him moving, it'd be like have to stop.
But then he wouldn't be at 0 either.
I want to know what the word.
Yeah, that's what I meant.
Yeah, we're gonna make it easy on us and assume that initial, no one's moving, final, everything's moving. Done? B, F,
1.
1F. Stop!
Wait,
Seriously,
there's
that's
really
like,
a difference between
sounds
BF1
so
and
bad.
1F.
Rare, Kramer.
Okay, try it.
Sassy.
B, 1F is what?
2.5.
No, yes.
And it's a positive 2.5, because it's right.
Do we need
Something for
velocity of the boat?
Wow.
So we've got M1, V1, I plus M2, V2, I equals M1, V not 2.
So there's 6 variables here.
Yeah, but 4 of them go bye-bye. No, 3 of them go bye.
Final.
4 of them go bye-bye.
M2,
No, when I
V2,
said there's 6, I mean there's M1,
F.
M2,
not
You're
stupid.
Wait, so
I know.
it's gonna be 0 equals something?
no.
The MI.
What can I cancel out?
All the initials.
All the initials. Those go bye-bye. So 0 equals.
0.
Equals 76.
Negative.
No, the first one would be 0 plus.
M1.
Right?
0 plus 0 is 0.
No.
Oh!
No, wait, this is
Get
0.
raised.
Right? Isn't this 0, not 0?
No, I wasn't. Never mind.
Oh.
I was going 76 times.
Alright, so M1.
Oh!
76.
Wasn't even me. Well, it was. Oh, look, that's a sign.
I did that shirt.
What?
Yeah.
Why?
So like,
We are brokens.
Change the ear on that. This one. Homosexual.
You guys just, oh, you guys are lucky.
I got the answer.
I am paying attention.
Alright.
does not have 0.
If you're paying attention, then I'm not referring to you.
Good.
What if we're doing both?
That's me.
Can you 100% fully do both? Is that
No.
possible?
Actually, in psychology, we learned about this. It is physically impossible.
There's no such thing as 100% multitasking.
Because the brain doesn't actually multifaceted. It goes between different things really fast.
Real fast.
I watched a video about it.
4.2.
Negative 4.
Wow.
Negative 4.2.
Oh,
I would probably just say 4.2 meters
Down.
per second.
Well, I thought you were
Down,
down.
down,
How did you say down? You going
How
underwater?
did you get that?
He's thinking.
If you jump off the boat to the right, won't the boat go to the left?
If you go down,
Is he like jumping off the dock down here?
Hold on.
He's jumping onto
Can
the
we say
dock.
negative? Can we say negative 4.2?
Onto the dock.
Oh, okay.
So have you ever come out of a boat onto the dock?
And you
What happens?
happens?
If you also hold the boat,
2.5.
well,
Okay.
I suppose you could say, technically we have to assume that we're like going straight horizontal here. Because if you do go up, then technically you have a portion that's going down.
So like,
Yes.
question.
Yes.
Can we say negative 4.2 meters per second to the right?
No.
You can't.
Why are you so
Please don't do that.
So negative.
Just leave it left off.
Remember, I think it's complicated as possible. Stop doing 6 things for it.
Okay, so notice how this equation is very similar in format to our mechanical energy or potential energy, kinetic energy conserved equation. You remember that guy?
Yes, energy is.
We had to figure out what variables cause things to go bye-bye. So now thankfully here, you got a whole bunch of masses and velocities. The hardest thing about these problems is really keeping object 1 and object 2 separated. Yes. Okay? That led to my really infamous quote that I said at the time.
So definitely a song.
So there was a homework problem where there were the 2 billiard balls. And I said, guys,
Oh, yeah. Oh, I know.
Wait, no, I'm serious. Sorry.
I said, guys, the hardest thing about this problem is keeping your balls separated. And first year, I think I had more infamous quotes from my first year than any year.
I hate it.
Hey, what about all this garbage?
Although I've had probably some of my worst drawings this year that
Nothing beats the cannon.
I appreciate this.
I wanted a photo of that kid.
It's online.
And Tarzan.
It is
I wanted to
online.
go find it, but I never
Oh.
did. It's classified.
Those goals.
Yeah, Bryce showed his mom.